Hello everyone, welcome to the channel. In my last video, I have covered how to create a Java thread in two ways, by extending the thread class and by implementing the runnable interface with practical examples. As well as I have explained which way is most recommended to create thread and why. Additionally, I have covered frequently asked interview questions regarding to start method and run method. In this video, we are going to discuss about constructors and methods of thread class. Basically, in this video, first I will explain thread class constructors with examples, and in the next video I will cover thread class methods. Okay, so we will be covering all of this in this video. So please keep watching until the end and you will get clear view about thread class constructors. Okay, so let's get started. So first let's understand what is constructor. So constructor is a block of code which is used to construct or to assign value to an object's variables, right? That already I have explained in Java constructor video in detail. So basically constructors are used to initialize an object variables, right? But thread class constructors are used to create threads. And this is the difference between normal constructors and thread class constructors. So always keep in mind, normal constructors are used to initialize an object variables and thread class constructors can be used to create threads. Okay, all right, now let's come to the point. So in Java, thread concept is based on thread class, and thread class has several constructors that can be used to create threads. So let's discuss what they are. So here I have listed out some basic constructors that we are going to discuss one by one. Okay, so this is the thread class no argument constructor, which is used to create a new thread with default name. So when new thread is created using this constructor, then JVM provide default name to each newly created thread. So when we use this no argument constructor to create thread, then a new thread will create with its default name. Okay, now let's implement this constructor practically. So for that, let's create a class, and it's suppose test class that already I have created, and inside main method let's create an object of thread class, and let's call start method on thread object. You can see here this is no argument constructor which will create new thread with default name. You can see here, just press Ctrl and click. So here this is inbuilt thread class, that is predefined thread class, and this is no argument constructor which we can use to create a new thread with default name. Okay, all right. So when I will execute this code, then we won't get any output, but a new thread will create with its default name. So why we don't get any output, let's understand. So when I will execute this code, the JVM start executing the main method, because in Java execution of program start from the main method, right? Then the first program control will come over here and thread object will create, or we can say a new thread will create using this no argument constructor, and JVM will assign default name to a newly created thread, and then program control come to this and thread execution will start, and JVM schedule this newly created thread by the help of thread scheduler. After that, thread will start executing thread class run method, because we doesn't extend here thread class and doesn't override run method. That's why by default thread class run method will execute, and thread class run method doesn't contain any code to print, and hence we won't get any output. You can see here, just press Ctrl and click. This is inbuilt thread class, and this is thread class run method. You can see here nothing is here to print, and therefore we don't get any output. Now question comes that is really new thread is created with default name, right? So let's check it out, and we can check it out by retrieving the default name of thread, and we can retrieve it by using getName method of thread class. So we can write here inside println method thread 1 dot getName. Okay, all right. Now let's run the code and let's see. You can see here we have got the default name of thread 1 and it's thread hyphen 0. It means new thread is created with this default name. Clear? I hope you understand how we can implement no argument constructor. Okay. So in this way we can use no argument constructor of thread class to create new thread with default name. Clear? Alright. Now let's discuss the another constructor. And this is another constructor. So this is parameterized constructor which is taking string name as an argument. So this type of constructor is used to create a new thread with the specified name. It means you can give specific name to the thread at the time of thread creation using this constructor. Okay. Now question comes at why do we need to give specific name to the thread, right? So if we think in a real-time multi-threading application, you might need to create multiple threads. Then in that case, it will be useful to give specific name to each threads to identify specific threads and their roles, right? And second thing is when an exception occur in a thread, the thread name is often included in the error message. And this can help you quickly identify which thread causes the error. So basically, giving a specific name to a thread can make easier to manage the multiple threads and handle errors in your multi-threaded application. Clear? Now let's implement this constructor practically. So for that, let's create another thread and it's suppose thread 2. Let's new thread and pass here a specific name that you want to give to the thread and it's suppose my thread 2. Okay, and start the thread 2 by calling start method on it. Okay, so this constructor we can call parameterized constructor which is taking string type argument. Okay, and using this type of constructor we can give specific name to a newly created thread at the time of thread creation. And let's get the name by calling get name method on thread 2 object. Okay, so we can copy, just change here thread 2. Okay, all right, now let's run the code and let's see. You can see here the thread 2 name is my thread 2. So in this way we can provide name to the newly created thread by using this constructor. Okay, or we can give name to the thread by using set name method also. So set name method is also available in thread class which is used to give name to the thread. So we can write here thread 2 dot set name and provide here name that you want to give to a specific thread. So we suppose my thread 2. Okay, and remove this from here. Okay, all right, now let's run it again. You can see here thread 2 name is my thread 2 that we have provide using set name method. Okay, so in this way either you can give specific name to the thread at the time of thread creation using constructor, or you can give specific name to the thread after creation of thread using this set name method. Okay, clear? Now let me comment out this line and provide here name. Okay, all right, now let's discuss the next constructor. And this is another constructor of thread class which is taking runnable object as an argument. So this constructor is used to create a new thread that will run the specified runnable object. Let's understand it directly through an example. It will be easy to understand. Okay, so for that let's create another thread and it's suppose thread 3. Okay, and let's start the thread 3 using start method dot start. And here we will need to pass runnable object, right? But wait, first let's understand what is runnable object and why do we need to pass it inside constructor. Okay, so when I will execute this code, then new thread will create using this constructor and thread will start. And JVM schedule this thread by the help of thread scheduler, and internally thread class run method will execute, because here we doesn't extend thread class and doesn't override run method, and therefore when thread will start, then internally JVM will run thread class run method. And thread class run method doesn't have any code to print, that already we have discussed, right? So thread class run method doesn't have any code to execute or to print, but it doesn't make any sense, because if we create thread, then we should allocate specific task to that thread so that thread will execute that task. And we can allocate task or we can write code for thread inside run method only, and we can override it from thread class or from runnable interface, right? So let's implement runnable interface. We can extend thread class also, but here we are going to discuss about constructor with runnable object, right? And for that we will need to implement runnable interface. Okay, and override here run method of runnable interface, public void run method. Okay, and simply write here hello my thread. Okay, so here I have implement a runnable interface and override run method. Okay, clear up to this? And now if I run this code, a new thread will create using this constructor and thread will start. And when thread will start, then internally by default thread class run method will execute, because here we have create thread class object and call start method on thread object, right? And therefore compiler look for the run method inside thread class, and by default thread class run method will execute. And thread class run method doesn't have any code to execute, therefore we won't get any output. But basically we don't want to execute thread class run method, we want to execute this test class run method, because we have written code for thread here to execute. But how compiler will understand that this test class run method have to execute, right? And therefore to make compiler understand, here we will need to pass this test class object. And test class object we can call a runnable object, because runnable object means an object of a class that implements the runnable interface. And this test class also have implement runnable interface, and that's why the object of this test class we can call runnable object. Okay, so let's create the object of this test class. Test new test. Now pass this test class object, or we can say runnable object, to this constructor. So let's pass it here. And now if I run this code, then new thread will create using this constructor, and thread will start executing run method of this test class, because we have passed here object of this test class, and therefore compiler will understand that test class run method have to execute. Clear? Now let's run the code and let's see. You can see here we have got an expected output, hello my thread. So in this way we can use this type of constructor to run this specific runnable object. Clear? Now let's move on another constructor. So let's go back to the theory part. So this is also one of the thread class constructor, which is taking a runnable object and string name as an argument. So this constructor is used to create a new thread with specific name and will run specified runnable object. Okay, now let's understand it practically how it work. So for that, let's create another new thread, and suppose thread 4, and start the thread 4 dot start, and pass here a runnable object, and it is test class object, right? Test object, and along with runnable object we can provide specific name to the thread. So it's suppose my thread 4. Now see here, we have already discussed the constructor with a runnable object. Same work this constructor will do. Only difference is that this constructor will create a new thread with default name, because we didn't provide here a specific name for a thread, right? And this constructor will create a new thread with specific name and will run specified runnable object. And we can check it out using getName method of thread class. So if I call getName method for thread 3, then we will get the default name of thread 3. Okay, and if I call getName method on thread 4, then it will give a specific name of thread 4. Okay, so just change here thread 4. Okay, all right. And we can do one thing to avoid the confusion. We can write here thread 3 name is. Okay, and here we can write thread 4 name is. Now let's run the code and let's see. You can see here the default name of thread 3 is thread hyphen 1, and the thread 4 name is my thread 4. So simply keep in mind, if you have to run specified runnable object along with if you want to give specific name to newly created thread at the time of thread creation, then simply go with this constructor. Okay, clear? Now let's move on another constructor. So let's discuss another constructor. Okay, so this is also one of the thread class constructor, which is taking thread group object and runnable object. So this constructor create a new thread in the specified thread group that will run the specified runnable object. Now question arises that what is thread group, right? So let's understand. A thread group is a group of similar threads, or we can say collection of similar threads logically. Basically, thread groups allow you to organize threads in a logical way, making it easier to manage and control them. Okay? So I will make separate video on thread group. But for now, simply keep in mind a thread group is a collection of similar threads logically, which is used to organize threads so that it can be easy to manage them together and control them together. Now question comes that why do we need to group similar threads, right? So let's understand. So assume that you are creating online shopping program, and there you may have multiple threads for handling incoming requests. Then you can group all threads that are handling incoming requests so that you can manage all similar threads together in the same manner and ensure that they are working together correctly and terminated. Clear? Now let's implement this constructor practically. So for that, let's create another new thread, and it's suppose thread 5. And here we will need to pass thread group object and runnable object, right? So runnable object we already have, but we don't have the thread group object, right? So let's create it. So thread group is the inbuilt class or a predefined class, and in that class there is a constructor, and using that constructor we can create thread group. We can see here. If I press Control and click, then you can see here this is inbuilt thread group class, and this is thread group class constructor. Using this constructor we can create thread group class object. Okay, so let's create it. And it's suppose group equals to new thread group, and pass here name for the thread group, and it's suppose my thread group. So this is thread group class object, and let me write this code here. Okay, now let's pass the thread group object and runnable object to this constructor. Okay, so thread group object is group and runnable object is test object. Okay, all right, and now start the thread 5 by calling start method on thread 5. And now if I run this code, then a new thread will create using this constructor that will belong to this thread group and will execute specified runnable objects run method. That is, this test class run method will execute, and we will get an expected output. And we can do one more thing here. We can check it out. Does this newly created thread, that is thread 5, is really belong to this thread group or not? Okay, that means we can get thread group name of thread 5. So for that there is one method in a thread group class, and it's get thread group. So we can write thread 5 dot get thread group dot get name. And here we can write thread group name of thread 5. Okay, that's it. Nothing we have to do. So we will get thread group name, and thread group name will be this my thread group, because here we have provided specific name to this thread group during the creation of thread group class object. Okay, all right, now let's run the code and let's see. So you can see here thread group name of thread 5 is my thread group, and here we won't get output in sequence. You can see here if I run it again, you can see here the sequence of output has changed again. So the reason is that when you create multiple threads, then JVM decides which thread to run next, because JVM schedules all the threads to run concurrently, and therefore order of threads execution can vary. And if you want sequential output in Java multi-threaded program, then you can use synchronization mechanism. That part I will explain in further videos. Okay, clear? Now let's move on next constructor. So the next constructor is this. So this is also one of the thread class constructor, which is taking thread group object, runnable object and string name as an argument. So this constructor is used to create a new thread with specified name which belong to the specified thread group that will run the specified runnable object. So we already discussed the constructor with a thread group and a runnable object, right? So this constructor is also same. Only difference is that in this constructor we can provide specific name to the thread along with thread group and runnable object. Okay, so let's implement it practically. So for that, let's create another new thread, and it's suppose thread 6, and pass here thread group, runnable object, and a specific name to a thread. Okay, so thread group is group, runnable object is test object, and provide here a specific name for a thread, and it's suppose my thread 6. Okay, all right, and now let's start the thread 6 dot start, and we can retry you, or we can get the name of thread by using get name method. So we can write here thread 6 name is thread 6 dot get name. So when I will execute this code, then new thread will create using this constructor, which will belong to this thread group, and will execute a run method of specific runnable object and has specific name to the thread. Okay, clear? Now let's run the code. Let's see. You can see here thread 6 name is my thread 6, and we'll execute a run method and we will get an expected output. Okay, clear? And now let's move on next constructor, and next constructor is this. So this is also one of the constructor of thread class, which is taking thread group object, a runnable object, string name, and stack size as an argument. So this constructor is used to create a new thread with specified name in the specified thread group that will run the specified runnable object and has the specified stack size. Okay, now question comes that what is stack size, right? So we know that every thread has its own stack that already we have discussed somewhere in previous videos, right? So when we create a new thread, then JVM allocate a new stack for the new thread, and each stack has its own default size. And if we want to increase the stack size, we can increase it using this constructor. So basically, stack size is the size of the stack that the thread will use to store its local variables, method calls, and other data. And if we don't specify a stack size, the thread will use the default stack size. Okay, clear? Now let's implement this constructor practically. So for that, let's create another new thread, and it's suppose thread 7, and pass here thread group, runnable object, and name for thread, and it's suppose my thread 7, and pass here stack size, and the stack size is specified in bytes, so we can write 024 into 1024. This is equivalent to 1 MB. And now let's call start method on thread 7. Now again question comes that why do we need to increase stack size, right? So sometime if a thread stack size is too small, then it can cause a stack overflow error. And second thing, a larger stack size can improve the performance of threads because some threads require a lot of stack space. Okay, and therefore sometime it's need to increase stack size. Okay, clear? And if we have to retrieve a stack size, then there is one method in a thread class, and it's get stack size method. Using this method we can retrieve stack size, but this method is deprecated since Java 5, and we can get the name by using get name method. Just change here thread 7, and here also thread 7. Okay, now let's run the code and let's see. You can see here we have got an expected output. That's it. So in this video I have explained all the basic constructors. In the next video I will explain about thread group in detail with example, and then I will explain thread class methods. Okay, now I'm going to end this session. Let's see you in the next session. Until then, keep learning, keep growing, and thank you so much for watching.